El Nino is a complicated phenomenon. I'm going to try and make it somewhat easy. In essence, what El Nino is just simply this. It's a warming of the eastern Pacific Ocean because of a backing up of the equatorial waters or the equatorial current. Now remember, if you're in California, you live on the western side of the North American continent, but that's the eastern side of the Pacific Ocean. The trade winds, do you remember those? They're found from 5 to 25 degrees in both hemispheres. They're an easterly wind flow, so they blow out of the east, also known as the tropical easterlies. Break down, that doesn't mean they stop, they just don't blow as hard. And this causes less of a push across the equatorial Pacific Ocean, which allows warmer water to flow backwards or eastward along the equatorial zone in the Pacific. That warm water then fans out along the west coasts of the American continents. If you take a look at this map, especially the left side, which represents the Pacific Ocean, notice this. When you're looking at South America, the west side of South America is washed by a cold water current indicated by the blue arrow. It's the Peru current or the Peruvian current. Then notice that California, the west coast of North America, is also washed by a cold water current called the California current, indicated by a blue arrow. Our current in California comes from Alaska, the Gulf of Alaska, which is cold by California standards, certainly. Now, if you look carefully at that map, you can see the North Pacific Drift, and this is indicated by a red arrow, which indicates warm water. However, this is warm relative to what it would be considering how high that latitude is. So you wouldn't jump in that water and think it's warm, because it's not warm. But it's warm relative to what it would be at that kind of a latitude, 50, 60 degrees in the northern hemisphere. Well, what happens is this. The California current and the Peru current more or less meet at the equator, and then they move across the equator towards Eastern Asia, towards Indonesia, Vietnam. Because of exposure to the sun at the equator, the current warms up, which is why you can see the red arrows indicating as you're looking from right to left, in other words, from east to west, going across the equator as the north equatorial current and the south equatorial current. They're warm simply because of exposure to the sun. This is a high sun zone in the tropical zone on our planet. Remember, the subsolar point is there in that area. I just indicated with a big red arrow a warm water current, which is the equatorial currents, going across the Pacific Ocean. Those white arrows indicate the trade winds. Well, as I said, the trade winds begin to break down for some reason, and when they do, that causes less of a push. It's a little bit like this. If you had a bathtub filled with water and you took your hand, you're constantly sloshing the water against the side of the water can stay up on the side of the bathtub as long as you keep sloshing it. But because it's a fluid body and because of gravity, if you stop sloshing it, the water's just going to flatten out. In a way, this is what happens, where when the equatorial currents have less of a push on them, the water begins to flow backwards. And as it flows backwards, indicated now by the red arrow that I put on there, now the water's going from left to right on our map, so it's headed from west to east. That warm water fans out along the North and South American coasts, and when it does, the cold water current dips down below it, and so there's a big pool of warm water that sits on the top of the Pacific Ocean in the Eastern Pacific. This is El Nino. If you take a look at these satellite photos, these composites from NOAA, you can see November 1997 on the left and July 2015 on the right. The red indicates warm water, and you can see there's a big pooling up of warm water headed towards South America. This is because that warm water is able to flow backwards because there's less push on it. And then you can see, especially in the July 2015 satellite photo, that the entire eastern side of the Pacific Ocean near North America is warming up. Of course, this is where we would get our maritime tropical air masses from, which is warm, wet air. Remember, warm air holds more water. And if the jet stream dips south and if storms are generated, what will happen is that will pull that warm, wet air into North America and in particular into California and give us heavy rain years.